underway. I'm going to go 60 seconds more tops, folks. All right, I think we've got about half of the people we're expecting. So we'll go a little longer and then we'll get underway. Thanks for joining this morning, those that have just popped in. All right, folks, I'm going to welcome you officially to the Oyster and Mussel Industry Energy Performance webinar. This webinar series is hosted by Seafood Industry Australia. It's in collaboration with the Fisheries R&D Corporation and the Blue Economy CRC, and you might have been to some of the other webinars in the series. So if you have, welcome back. If this is your first one, thanks so much for joining. I would like to just acknowledge that I'm on Nurrinjeri country in South Australia, near the mouth of the River Murray. It's very windy and very cold this morning, and the rain's coming in sideways, and I hope it's doing as much as it can to break up this algal bloom that we've got going on in our neck of the woods at the moment, which we're very ready to see the back of. This project that this webinar series is a part of is about decarbonising the aquaculture sectors and finding options to do so. And a part of the project has been to build sector profiles for 6 different aquaculture sectors. Today is obviously all about oysters and mussels. And I just wanted to say to the oyster folks online, thank you so much for your engagement with the project, because it's been, I think, the best of all the sectors, and we've had a lot of feedback through the surveys. Even going back to a meeting in Port Lincoln that I attended, the room was full. We had really good engagement. Thanks, Linley, for putting that show on and inviting me along. So I think the data we've got for the oyster industry in particular is really good. That data's flown through to ERM and Ross Tunmer's team in particular. He's joining us today to give a little bit of a background of the sector profile. And we thought we'd have Ross present for about 20 to 30 minutes this morning, and then we can open it up for questions at the end of his presentation, and have a bit of a discussion then if there's anything you want to chat about. So welcome, Ross. Thank you, mate. And it's over to you when you're ready. Thank you.
Great. Thanks for the introduction, Tom, and thanks everyone for having me. So yes, my name is Ross Tunmer from ERM. If you haven't heard of ERM, we're a pure play sustainability consultancy. We'd like to think we're the largest in the world, actually. Personally, my background, I'm a mechanical engineer by trade and have been in the sort of consulting world for close to 15 years now, mainly in sort of heavy and energy intensive industries, consulting around energy efficiency, energy feasibility studies, renewable energy, things like that. So yes, I was involved in this project, and we crunch some of the numbers around the energy in your industry. So yeah, I've got a fair bit of content to get through. I don't want to take up too much time. I want to leave plenty of space for Q&A at the end. So without further ado, I'll share my slides and get into it. Can everyone see that all right?
Got them. Thank you, Ross.
Excellent. All right, so these results are sort of presented in two parts. So firstly, around the grow out part of the sector, and then also we'll have the same sort of set of slides for hatcheries as well. And it's important to note that we've got a lot of responses from the oyster industry, but I think there's only one data point from mussels, but hopefully a lot of the same information applies regardless. All right, so here's a snapshot overview of the sector. Probably no surprises to those in the room. So based on the survey responses, quite a wide range of different production volumes across different organisations, from 50 to 5,000 tonnes per annum, and annual revenues ranging from 1 million up to 10 million plus, and quite a range of number of employees too. So an average there of around 13 full-time employees, and then some part-time and seasonal, 1, 2 or 3 part-time or seasonal employees coming on throughout the season. And I guess as a sort of summary of the industry structure, I think the vast majority of operations will be estuarine aquaculture, but there might be some on-land systems as well, some flow-through systems or recirculating aquaculture systems. But I think that probably applies a bit more to the hatchery side of things. But there might be a handful of operations that are on land. And you can see the map there that's just summarizing where all the operations are. All right, so based on the survey responses and some of our industry knowledge, here's a sort of snapshot of where the energy goes in your operations. So you can see it's split predominantly across 3 categories there. You've got cultivation energy needs, processing energy demands, and then the auxiliary energy uses around that. So the cultivation relates to, a good chunk of that will be diesel use in your vessels, in your vessel operations. There'll also be a fair bit of electricity use across pumping, and if there's any aeration or filtration that you're required to do, if applicable, and then some temperature regulation as well, if that applies. That's going to be a good chunk of your energy consumption and costs. I think, yeah, around about generally speaking, 2/3 of energy costs as relates to the diesel use, and then maybe 20 to 25% of electricity is around pumping. So the second category there, you've got the processing energy demands. So when you bring everything on land, so a good chunk of that again will be the cooling and refrigeration requirements for cool rooms and freezers, which is obviously going 24/7. And again, that can be up to sort of 50% of your electricity consumption. And then there's all the other bits of equipment, so the grading equipment, and then other processing facility operations. You might have compressed air and pneumatics on site. And then thirdly, the auxiliary energy use. That's probably more on the 10 to 15% of your electricity use, and also a bit of extra diesel use there for vehicles to and from site, and then administrative facilities, so offices, and then lighting as well, and maybe a little bit of HVAC in there. So yeah, that's where based on the survey results, that's where most of your energy goes, if not all of it. You can see over on the right side there, the annual energy use, quite a range across the different organizations. So some of the smaller ones are, 2.5 to 10 megawatt hours per annum, up to some of the larger facilities, which are quite energy intensive, 300 to 1200 megawatt hours per annum. Similar story for the diesel, quite a range there. Some of the smaller operations, 100 to 2,000 litres per annum, whereas some of the larger sites will be 20,000 to 250,000 litres per annum. And again, some smaller, comparatively unleaded fuel use as well. The vast majority of energies across diesel and electricity, and a little bit of LNG thrown in there for some of you as well. As far as when energy is used, you can see there consumption is predominantly throughout the daytime, but there's also some consumption overnight, and again that's generally related to some of the cooling and refrigeration systems that are on 24/7. As far as seasonal variation in energy consumption, there's a little bit more energy consumption in summer, and that probably relates a bit to the weather, a bit more load on the cooling and refrigeration, and just the seasonal differences as well. All right, so we've outlaid where the energy goes generally on site. So how much does it cost? So once again, there's quite a range across the surveyed organisations. So some of the smaller operations are, as small as 1,000 per annum, up to maybe 100,000 is probably a more typical number. But then some of the larger organisations will spend hundreds of thousands on energy, up to $500,000 per annum. Quite a wide range in the average electricity rate as well, and that probably just correlates to how much energy you use. The more you use, generally speaking, the cheaper the rate you'll be paying. So quite a range there as well, 15 cents up to 50 cents per kilowatt hour. It also relates just to physically where you are and how remote you are. So some of the higher costs might be in those regions where you've got high network costs. Average fuel, less of a range there, but typically, $1.73 to $2 per litre. That might be changing as we speak. That's always volatile, those numbers. And I guess the average energy cost per tonne of production, one organisation might be $450 per tonne, another might be close to double that, closer to $800 per tonne. So again, that's quite a wide range there, and it'll be very site specific and depending on what kind of operations you have. Based on the responses, as a percent of your operational costs, energy is typically quite a large chunk of it. So anywhere between 10 to 30% of your operating costs. So anything you can do to reduce those costs, obviously hits the bottom line. Just some energy cost challenges there. So obviously, in today's climate, I could spend a whole webinar just talking about this, but energy price volatility is a big concern these days. A lot of it relates to gas, which impacts electricity rates, but also diesel and petrol prices sort of tend to be quite volatile these days too, although it's been a bit more stable in recent times. But generally speaking, the sort of recent trend is rising prices, but hopefully that's plateauing into the 10, 20 year range. I understand from the survey responses, I'll talk about it soon, but grid outages are quite a big factor in your industry and it can impact operations quite frequently. And I guess for some of the more remote operations as well, it's hard to connect to the grid, so you're relying on diesel generators for some of your operations as well. And trying to connect to the grid can be quite a big cost and a bit of a barrier there. Related to that, I guess if you're looking to install solar, sometimes there's restrictions that the network companies put on what you can do, simply because they don't want to allow too much to be fed back into the grid, or they'll just not let you feed back any at all. So that brings up the topic of battery storage and things like that. To the right there, you can see some of the energy sources as a percent of all those who responded. So it looks like everyone there uses grid electricity to at least to some extent, but there'll be some operations that are hybrid, will have parts of their operation off grid and will use diesel generators. So it looks 40% respondees, and then a fifth of respondees already have solar PV on site, which is great. Vessel usage the harvesting vessels, obviously that's a big part of operations and energy spend as well. That'll be, diesel consumption is a big component of energy costs. And yeah, that's a bit of a snapshot of the energy profile from a cost and how much you actually use rely on off-grid operations as well. All right, so what are some of the, I guess, energy-related opportunities and challenges for your sites? So I guess one thing to consider is hybrid diesel-electric vessels. I'll talk to it in a bit more detail on the next slide, but this is, I guess, technology that's coming along. It's not, as widely available as, say, hybrid and electric road vehicles, but I think there's more and more options coming onto the market, and it could be something that you might want to try piloting if they're considered looking into it, as it is a big component of your energy costs, and the electric hybrid versions, in theory, have lower OPEX, but obviously there's the CAPEX aspect of buying these vessels, so it might be something that you want to pilot first. Another opportunity is on-site solar PV and battery systems. So I think that'll be an opportunity for most sites, depending on how much land and your buildings that you have. Space could be a constraint for some of you. I think for all of you, the efficiency will be an opportunity. So especially around the pumps. Is that my building alarm going off? Can you believe it? My fire alarm just gone off.
Yeah, safety first, Ross. If you need to do something that's not sit in front of a computer while the alarm goes off, mate, you better go and do that.
I'm gonna walk with my computer and see if I can keep going. But sorry about this. That's bad timing, isn't it?
That's okay, mate. We can adapt. So don't do anything that's going to get you in strife, mate. I'm happy to just have a conversation with the folks online, and we can think about how to recover. But I don't expect you to. No, you hang up, Ross. I think. How are you going?
Tom, can you hear me?
I can, Simon.
Might not be a drill. Can you still hear me?
Yep, Ross. I'm pretty comfy, mate. If you want to go and get evacuated, Simon Wilcox is online, and I'm hoping he might be able to talk through what he knows about the sector profile, mate. So look, log off, Ross. We'll speak.
I'll return. Yeah.
Good. Thank you, mate. Yeah, well, this is a new one for me, folks. So I'm going to do my best to keep the show on the road. But yeah, Simon, are you there, mate? I just heard you stick your hand up.
G'day, Tom. I was just going to ask one of the participants actually if they might be interested to make some comments. So we have online. I can see Gavin Partridge, who works with Harvest Road, and Gavin and Harvest Road are doing a pilot project on hybrid vessels as part of this broader decarbonisation program. And seeing as how Ross had just been covering off on it a little bit, I thought it might have been, and we've got this break, I just thought it might have been just a good opportunity, Gavin, if you were happy, just to have a bit of a chat about that pilot project.
Thanks, Simon. Can everyone hear me okay? I'm sorry, I'm just on my phone. I'm just on my way to another meeting, so hopefully you can hear me.
Sure, got you, Gavin. Thank you.
Excellent, thanks. Yes, Simon said, yeah, we've just recently started a project in collaboration with the CRC on vessel electrification. We've only just signed the contract, so it's still very much early days, but we have made some progress. Commissioned a very knowledgeable consultant in this area and have been reviewing sort of what's available worldwide in terms of electric boats. So not really looking at hybrids at this stage, just pure electric. And I've got to say I'm pretty impressed by how things have come along in the last couple of years. There are some pretty impressive looking boats out there working in the commercial oyster industry. And as part of that project, we will be putting together a bit of a survey that we're hoping to sort of share with everyone to get everyone's thoughts on electrification, what they might want to see from it, Yeah, just asking questions about, any concerns, things like, what sort of range do you need? What sort of weight do you need to carry? All those sort of important considerations. But yeah, as I said, we've been very impressed with what we've seen so far, and yeah, hoping to pilot something in the future. So you're happy to take any questions on that or anything else you wanted me to cover there, Simon?
Oh, that's great. Thanks, Kevin. I just thought it was worth mentioning. It is a big opportunity in the oyster and mussel sectors to have, to target electrification of vessels, and we look really forward to seeing what the outcome of some of the analytical work that you're doing is. That'll talk about capex, opex, payback, and general business case parameters to just so people can see how that stacks up, and that'll be part of the information that's reported back through this project. So that should be pretty interesting and valuable.
Yeah, that's right. Yeah, and that's why we want to get everyone's input, just to make sure that business case is broad and covers off the whole range of vessels that are used in the industry, and all the different requirements there are for different size operations with different size vessels and that sort of thing.
Yeah, thanks very much.
Whilst I've got the soapbox as well, Simon and Gavin, can I ask a question, Gavin, about, from a business perspective, when you're going through your P&L and you're reviewing different expenditure line items, is electrification of vessels something that is one of the sort of more low-hanging fruit? Is that why Harvest Road is pursuing this? Is it something that's pretty achievable and actually going to give you some, monetary benefit at some point too?
Look, hopefully down the track, I think it's fair to say that electric boats aren't as far along as electric cars. They are still more expensive because they are so new. In terms of low-hanging fruit, the fact that there are ones out there now that are working in the oyster industry is encouraging. I think there is lower-hanging fruit in terms of just general solar on the roof of your sheds and that sort of thing. How long it takes to fully electrify a fleet, all the things around, charging logistics. One of the barriers, I think, in the short term is going to be AMSA regulations. Currently, there's an exemption under AMSA for any boat that's got a battery capacity of less than 30 kilowatt hours, and 30 kilowatt hours isn't not going to get you very far in your day-to-day operations. So I think there is going to be some regulatory hurdles to overcome, but that's part of this project. We will be talking and have already started discussions with AMSA on a path forward, and just looking at what's been done overseas to try and help smooth that regulatory pathway.
Yeah, sure. That's good advice, mate, because you probably already know this as well, Gavin, and probably the folks online. And there is another part of this project, which is developing a policy directions paper and information like that with respect to getting vessels in survey, particularly if they've changed propulsion systems. That's something that I think will form at least a section of that policy directions paper.
Yeah,
Robert.
And whether you can retrofit a vehicle or it has to be a new build, they're the sort of discussions we're having with AMSA. In theory, it's quite easy to retrofit if you're using outboards. But yeah, what the regulations say about that, we're unsure at this stage.
Sure, no, understood. Thanks, Gavin. Hey, Robert, from the FRDC, you've got your hand up.
Yeah, thanks, Tom, and apologies all for the quality of my voice. It is not your audio. Look, really great to have everybody on this webinar, and Gavin, particularly to be able to listen to you and to hear that you're really excited about joining the project with the CRC and SIA and FRDC. One question I have, and maybe Simon, you may be able to answer this in Ross's absence, but I wonder, the amount of diesel which is used for generators, I'm guessing is separate to the fuel which is used for outboard motors and marine vessels. So is the fuel for gensets and about is that another area energy and decarbonisation, which is an area that is also an opportunity to be able to look at, being able to try and somehow either use renewable electrification or other technology which is not the same as the boats used in outboards and things like that.
Did you want to say anything there, Gavin?
Yeah, sure. Thanks. Yeah, good question, Rob. That's going to form part of our survey and what people are using diesel for, whether it's in the vessels directly or in generators, particularly on our farm. Nearly all of our boats themselves are unleaded, but yeah, we do use gensets, and yeah, we are looking at options under that same project for battery power packs, mobile battery power packs, and the like, to help offset the use of diesel in gensets.
That's great. Good to hear. Thank you.
I think Gavin just made the point, but in the oyster and mussel sector, the predominance of vessels are unleaded outboard powered vessels. Although I do believe there are a smaller number of sort of heavy works, more displacement type vessels that will be diesel powered and have all the lifting equipment and so forth on them. Then there's also the land based element, Rob, as well, which is I think there is at least one example of a hatchery that is off grid, and so it relies entirely on diesel generation. But otherwise, the majority of people just are using diesel in that circumstances for backup generation.
Might take one last question from Ron Tremaine before we hand back to Ross, who is alive and well by the looks of things. So yeah, Ron, did you have a question you wanted to ask?
Yeah, thanks, Tom. I was actually just following on from Simon's point there. So we're the one hatchery that is off grid, and it represents our single biggest cost reduction opportunity, operational efficiency opportunity, but also environmental opportunity as well. We have really struggled to find an optimal solution. We're currently working on a project to source hybrid systems that deliver against those three areas. So again, any opportunity to participate in the project to solve that problem would be one that we would definitely sign up for.
Well, thank you, Ron. Appreciate that. Ross, are you happy to pick up where you left off?
Yes, I can. Sorry about that. Sounds like a false alarm. I'm now downstairs in the cafe. Yeah, sorry about that delay. I'll reshare screen, but it sounds like you were having conversations around vessels and I guess off-grid solutions. Is that right?
More or less, mate. Absolutely. Sort of on the back of your last slide.
Yeah, very good. So I'll just return that. All right, can you all see that?
On my screen, it still looks like it might be loading, Ross. So I've got a blank screen at the moment, but can anyone else chime in if they can see slides? No, looks like it's blank at this stage, Ross.
Really? Okay. Should be showing a window. Can't see that?
No, sorry.
He seems a bit glitchy too, Tom.
Let me try again.
Yeah.
Sorry about this. I had a very good setup shortly.
Just to check, Ross, you did use the presenter link to sign in, the same one as last time? Cool.
Yeah.
No probs. And you've also the video quality isn't the same as it was before, so I'm just wondering if you've got some connectivity issues. Now I've got you. We've got the presentation.
Okay. Yeah. I've turned my camera off too. Hopefully that helps things.
Sure. Great. Thank you, mate. All yours.
All right. So where was I? Okay, I think I was just going through some of the opportunities and some of the challenges as well. So yeah, I guess the availability of the low carbon vessels is a topic, and I think you were talking about that for the last 5 to 10 minutes while I was offline, so maybe I won't expand on that, but it's an emerging technology, and obviously grid connection and power outages seem to be a concern in the industry as well. So you can see in the graph on the right there, power grid outages is affecting roughly a fifth of organizations, and also generator failure. And the impact on operations, can be up to 2 hours per week throughout the year, and it can have quite a big impact on operations. So that's something of concern in your industry. So when we talk about energy, we also talk about carbon emissions. And this is a snapshot of your industry as far as what action's been taken by organizations. So you can see there that over 50%, close to 60% of organizations have undertaken baseline emissions data assessments, and so built that carbon inventory, so they have a good understanding of where carbon emissions are and what your baseline is. But no one's quite got to the step of tracking that from year to year, which is that scope emissions tracking. But I guess now once you've set that baseline up, you can target and track emissions over time. As far as decarbonisation planning and implementing initiatives, you can see there in that bottom left graph, a lot of the planning has occurred or is occurring, which is great. Most of you have considered renewable energy, so I assume that's predominantly looking at solar energy and maybe battery systems, if that applies to your site. A relatively low percentage have considered energy efficiency opportunities there, and I would suggest that there's probably a fair amount of opportunity to optimize on-site energy efficiency there, particularly when it comes to pumping, compressed air, and any of your refrigeration and cooling systems. There's often a lot of relatively low-hanging fruit or even medium-hanging fruit to attack there, and you get pretty good payback on a lot of opportunities that are implemented. And energy storage has not really been considered for a lot of you, but it's probably something that will increasingly be considered. Now, on the right there, that's sort of a summary of a lot of the decarbonisation technologies that could be considered. If you haven't heard of the TRL scoring before, that's sort of the technology readiness score, and the highest you can get there is 9, so it's a scale of 1 to 9. 9 basically means it's totally commercially proven, it's been out in the market, it's well tested and known, and there's lots of companies out there offering it and lots of competition. Whereas the other end of the scale, 1 would mean, it's sort of a blue sky idea. No one's really got it out of the lab, or it's barely been tested in the lab. So it's very new technology. So somewhere in the middle there, 5 or 6, it's emerging as a commercial opportunity. So you can see there a lot of the energy efficiency in solar battery systems, they're pretty well proven. Battery systems, they're not quite a 9 because there's still improvement and costs are coming down quite rapidly over the last few years. So there's a lot of movement in that battery space, but yes, energy efficiency and solar are pretty well proven. Wind gets a score of 7, that's more in your industry. Wind generally is well proven, but I guess the potential at your specific site will be very site specific, whether or not there's a resource there, and it has a lot of different sort of issues. Generally scale is important there. You want a bigger wind turbine, the higher above the ground and the larger the turbine is, the more bang for buck and the better payback you get on it is. So it really depends on the size of the operations. I would say that one only really applies to some of the larger ones in extremely windy spots, if at all. You can see the hybrid diesel electric vessels, that gets a TRL of 6. So it's sort of a emerging solution, and I think you had a bit of a discussion about it before, but I think that'll be increasingly applicable over the next 5 to 10 years. There'll be more options out there. And just a list of resources to assist there as well. There's a lot of financial subsidies out there, lots of grants around. I don't know if any of you have used AI recently, but AI is getting very good. Ask ChatGPT or Copilot what funding's in your area, and they're pretty good at tracking it down, better than Google, I'd say. All right, so just to wrap up the grow out, the farming side of the oyster and mussels. So as far as recommendations go, short-term actions, I definitely pursue, investigate whether there's energy efficiency opportunities, particularly around your refrigeration. If you have aeration, your pumps, compressed air, there's probably a lot of gains to be had there. And obviously investing in solar PV where you can to reduce your operational costs. And usually systems, should have pretty good paybacks, especially with some of the energy costs your industry seems to be experiencing, especially in the more remote areas. I guess the one barrier there would be how much you can export back to the grid, and that's where battery systems might come into play and have a bit more of a role on your site. The medium-term initiatives there, that relates to the battery storage with the solar system. Wind turbine might apply to your site if you have a wind resource, and then again trialing, maybe starting to pilot some low carbon vessel alternatives. And then I guess some of the longer term is transitioning any of your fleet to electric vehicle if that's applicable. There might be some more innovative wave or tidal power applicable. That's sort of an emerging technology. It's not that well proven globally, but you might have a unique situation where you can utilize wave or tidal power. And I guess over the long term, ideally you want to get your operations to net zero emissions. And if we're talking about, science-based targets, trying to keep global warming to a reasonable level, we're always talking about net zero by 2050 and trying to stage that over time from now into the future. So when we talk about, you've measured your baseline emissions, now you can start targeting your reductions over time and have a target reduction by 2030, 2035, things like that. All right, in the interest of time, I might keep moving onto the hatcheries energy profile. So similar slides again, but just the results from the hatchery side of things. So a bit of a range there in the production volume, so between 50 to 150 million spat per annum, and annual revenues again between 1 million to 5 million per annum. The number of employees, the average amount is 5, and a small number of 1 or 2 part-time or seasonal employees as required. As I alluded to earlier, this is where you're having more of your recirculating aquaculture systems and your flow-through systems on land. And you can see the map on the right. These operations are a bit more narrow in Australia across 3 states. So where does energy go at the hatcheries? So a lot of it, or the vast majority, is around pumping and aeration / filtration. Depending on your location and your sort of how much temperature regulation you need to do, that can also be a big component of your operations if you're needing to cool water. And then feed systems and other equipment make up 10 to 20%. And then auxiliary systems generally don't account for a whole lot, but you might have some small offices or lighting and a vehicle or 2 depending on your needs. So a bit of a snapshot on the right. So the average amount of electricity consumption per annum is about 500 megawatt hours per annum. Fuel use has quite a range, and this probably relates to whether or not you've got a diesel genset using diesel. So anywhere from 20,000 litres to 250,000 litres. So that's probably the example that was mentioned earlier. Site that's off grid, and a little bit of unleaded fuel as well, and a little bit of LNG for some sites. In comparison to grow out, energy consumption at hatcheries is a bit more flat across the day, so it's a bit more flat 24/7, and there's less seasonal variation according to survey responses. Again, there's a bit of a I think there's less data points for this one, but it seems like the average electricity is a bit higher than the grow out facilities for some reason, averaging 35 cents per kilowatt hour. And I guess the average cost per unit production is only 16 cents per unit. I'm not actually sure if that's per spat. Maybe that's why that number looks so low. And as a percent of operational costs, it's around that 10 to 20% of overall operational costs, which is quite similar to the grow out facilities as well. So again, it's a decent component of your spend. So any efforts you can do to reduce those costs can have a big impact on your bottom line. A lot of the same sort of energy cost challenges as are at the grow out as well. You know, that rising electricity and volatility across fuel prices. Grid outages looks like it's even more prominent across the hatcheries for whatever reason. And yeah, it looks like there's, if you look at the graph on the right, there's a bit more use of diesel gensets as well. Again, only a small uptake or a small amount of energy is provided by on-site solar PV, similar to the grow out as well. The opportunities are not too dissimilar. So again, you've got the solar and battery. Pumps is probably a bigger component for hatcheries. So any sort of opportunities around, you know, pump efficiency, if you can operate pumps on VSD, not have them circulating unnecessarily. Any efficiency around the aeration side, so high efficiency blowers or VSD controlled to optimize it, or with fine bubble technology. Generally, that's a better way to oxygenate per kilowatt hour if you can. And again, lighting and grow lighting efficiency and refrigeration system improvements is usually a big opportunity as well. Similar challenges for hatcheries as well. So grid connection for remote, it can be costly, and then obviously diesel genset can be an expensive way to generate electricity, and power outages if you're grid connected, something that needs to be managed with backup gensets. On the right there, you can see some of the different typical energy disruptions. So, you know, a good chunk of the industry has experienced generator failure, grid shutdowns due to maintenance, or just general power outages, which I would say is a bit higher than other industries, just generally because of the locations you're operating in. And obviously that has impacts on your operation. When we talk about carbon emissions, so maybe slightly less than the grow out side of things, but 40% of you have looked at your baseline emissions and determine a carbon inventory, so it's a starting point. And then again, that same 40% has started to plan decarbonisation and how you might get to net zero by 2050. And again, 40% have already looked at renewable energy. Once again, energy efficiency is only a fifth of you responded as having considered energy efficiency. So that's probably another area of opportunity, I'd say, especially around your pumping and your aeration. On the right there, a lot of the same technologies are described. Again, the wind, I would say that's very, very site specific, and potentially because the energy consumption at the site is not as large, it might not be applicable because you really get economies of scale with wind. You kind of need a big site to use it directly. Otherwise, there's not very good payback on that capex. And again, there's some resources you can utilize to further investigate how better to manage your energy and look at energy efficiency projects and solar and things like that. Once again, this has been divided into short-term, medium-term, and long-term. Again, I'd highlight that the energy efficiency is probably something to consider in the shorter term, and consider solar PV if you haven't already. Where you're off-grid, you might have to look at more complex setups, and battery storage might be applicable to sites where your network provider restricts how much you can export back, or you have very narrow windows of energy consumption, so you want to sort of shift where the generation, the solar generation is used on site. That's where paybacks would we have battery batteries having payback. Again, wind turbines are very site specific, and in the longer term, I guess you would consider more innovative low carbon generation. Wave and tidal still very much emerging, and you would look to implement a decarb plan to get to net zero. I think I've probably spoken enough, and we'll probably leave a bit more time for Q&A, and I can revisit any of those slides as you wish. Actually, don't know what time it is. Okay, it's 10:45.
Yeah, thank you, Ross. We've got 15 minutes, or just less than 15 minutes for some Q&A. If anyone has any questions of Ross, feel free to put your hand up in Teams and I'll get around to you. One thing I'd also like to ask Ross, but also other participants is in putting together these sector profiles, that's not the end point of the data that you've provided to the survey. We're also looking at that policy directions paper and what are some barriers that we can try to clear for industry in order to actually get these things implemented. I mean, one of the most obvious ones is there's obviously a cost to play when it comes to purchasing new technologies that are more energy efficient. But I'd just like to open it up to anyone who'd like to have some input into that policy directions paper about what they might want to see changed or done differently or improved in the policy landscape going forward for the oyster industry. So over to you. While Ross was talking, I googled a grant scheme that was brought in South Australia. I think it was probably just over 12 months ago, called the Energy Efficient Grant Scheme, which was about allowing businesses to apply for funding to complete one of those audits that Ross mentioned. So actually look at your own business and whether you can make some small improvements to save some money, which I thought was probably not a bad idea, but I'd like to fact check that with you folks. Andy Myers, did you have a question or some input?
Yeah, I kind of mimicking kind of Gavin's comments before around the low-hanging fruit, particularly around the PV panels and batteries. That's certainly the low-hanging fruit. We've just done basically a statewide assessment in New South Wales of where we sit as an oyster industry, and about 45% of all our greenhouse gas emissions were coming from unleaded fuel use in vessels. So even though the low-hanging fruit is in your solar panels and batteries, in terms of our decarb journey, opportunities to get more trials happening around electric vessels, certainly, and anything that can pave the way to facilitate those trials. I wasn't aware of those AMSA issues before, so anything that could assist in that space would be really useful. But I suppose in the broader kind of context, once you look at the oyster industry and probably the mussel industry as well, compared to other proteins, our greenhouse gas footprint is very low. Even without any changes, we can actually offset the whole of the oyster industry's carbon emissions in New South Wales for about 100,000. So puts it in context, but clearly there's always more we can do. But just in terms of context, I thought I'd mention that.
Absolutely. I was thinking about that, about talking about that in my intro, Andy, about how there's not a heap of sort of wiggle room for the oyster and mussel industries on that, I guess you call it the emissions reduction side. Any news or any ideas around the sequestration side? Is that something you're still sort of pursuing or thinking about, or is it kind of redundant if you're already so close to zero?
I think it's a little bit redundant, to be honest. We can't claim that the actual sequestration in shell is a carbon dioxide reduction mechanism. That's a failed argument, I think. So we probably need to look at ways of just reducing our our emissions and offsetting the residual amount at the end.
Sure. Yep. Very interesting. Thank you.
Just one thing that I guess wasn't covered in the presentation was your scope 2 emissions, and I guess that that in theory that could be covered off by a renewable energy PPA or buying renewable energy credits or LGCs to remove those emissions effectively. And I guess carbon offsets as a general topic hasn't been discussed either, but that's almost a whole nother presentation, and you can talk for hours on the different merits of different types of carbon offsets and their validity. And I'm sure a lot of you have heard of some of the controversy around some of the different types of carbon offsets. But when we talk about science-based targets, if that's something that's on your radar, they have a lot of criteria around the types of carbon offsets, and they really only want you to offset the last 10% of your emissions. So they'd rather you actively get rid of your emissions in a physical manner, and then that last 10% is where you would attack it with carbon offsets, and they prefer offsets that are actually removing carbon, not offsets that are generated from avoided emissions or those kind of offsets that might have a bit of controversy around them. So just something to mention. And I guess from a carbon accounting perspective, it's important to note that LGCs or RECs are not, from a SBT perspective, they're not considered offsets as such. They're just a valid way to remove your scope 2 emissions. I have to be careful. I often use the word offsets, but they're not technically not offsets, but they do can remove part of your scope 2 emissions.
Sure. Thanks, Ross, and thanks, Rob, for your comment in the chat as well, which I completely agree with. It's sort of a good opportunity, or oysters have a good opportunity relative to some other sectors where there's maybe not as much, or you're coming off a worse foundation to have to reduce a lot more diesel, or you don't have an opportunity for electric vessels, at least in the next, maybe 10, 15 years possibly. Now, I'm not seeing any other hands up, folks. We're pretty close to the end of the webinar. I'm comfortable, as Veronica would put it, to give you back 7 minutes of your day, if that's okay with you, as I'm sure it is. If you do have any queries of the team or of Ross and his team, feel free to get in touch. You should be able to see the webinar, the recording put up on any of the FRDC, Blue Economy or SIA websites, but I think the Blue Economy CRC website is where the other webinars are posted at the moment. You'll probably get an email to the address you used to register for the webinar. Thanks so much for joining. Thanks, Ross, for your presentation, Simon, for your input, and all of the participants. Have a great morning, and we look forward to being in touch. Thanks, everybody.
Thanks, Tom.
Thank you.
Yeah.
Thanks, Tom.